I'm Nick Bostrom. I'm a professor at Oxford University where I direct the Future of Humanity Institute. Assuming science and technology continues to progress, we will find ways to generate general intelligence in machine substrate. And that at some point after that we will have machine superintelligence, machines that exceed human intelligence in all domains. So I've long been interested in certain future technologies because it looks to me that they will be among the key determinants that might shape not just this century but all future for Earth-originating intelligent life. I think that this century or maybe the next will be a key bottleneck. If we make it through, then our descendants might colonize the universe and there might be these enormous values coming to be realized. And you can run some rough calculations of that if you figure that there are billions of galaxies with billions of stars each of which could live for billions of years. There's just like an enormous amount of potential value in the future. And I think that whether that future will in fact be realized or not might very well depend on some of the choices we make in this century, particularly whether we manage to be savvy and responsible in the way we develop certain key technologies, AI chief among those, but also synthetic biology and nanotechnology and a few others.
Good evening. I'm Alan Shreese. I'm the president of the Chicago Council on Science and Technology and the director emeritus of Argonne National Laboratory. I am certainly pleased to see you all here on this important topic. The Chicago Council on Science and Technology mission is to raise the awareness of the critical importance of science and technology in our society, and this program certainly measures up to that challenge. Those of you who enjoy the program and look at our other programs and wish to join the organization, you can sign up outside. I would like to introduce, I plan to introduce Brenna Berman, who is the Commissioner of the Chicago Department of Innovation and Technology, Chief Information Officer of the City of Chicago, but most of all, a member of the Board of Directors of Chicago Council on Science and Technology. Brenna, who will introduce the speaker.
Thank you. So tonight's program is very exciting and a perfect example of why I love being a board member of C2ST. Tonight's program, Superintelligence, Paths, Dangers, and Strategies, is a perfect example of how C2ST works to engage the people of Chicagoland with the science that goes on here in the community. Tonight, Dr. Nick Bostrom is going to talk with us about, is going to be taking a closer look with us at the darker side of computer intelligence as machines approach the eventuality of surpassing human intelligence. Dr. Bostrom, who joins us from Oxford University, is a professor of philosophy. He's director of Future of Humanities Institute and also director of the program on impacts of future technology. He has a background in physics, computational neuroscience, mathematical logic, and philosophy. That unique background has brought him to look into things like the likelihood that computers will eventually surpass humans in intelligence, and that such an event could be very dangerous to humanity, and the strategies and implications that we should consider when such an event occurs. Following his talk here today, he'll be engaging in similar discussions with organizations such as Microsoft and Google, as well as the Machine Intelligence Research Institute at UC Berkeley. We're very lucky to have him here tonight. He has published over 200 publications, including 4 books, one of which is available here tonight, and he'll be signing copies and answering questions after his speech this evening. And I think it's very, very exciting that C2ST, this organization that we have here in Chicago, can bring such exciting information to us in such a casual setting. So I'm very excited to welcome Dr. Bostrom here this evening to discuss such an interesting topic with us here. Dr. Bostrom.
Yeah, thank you very much for the invitation to come here and for all of you to turn up. So the book is mainly about superintelligence as a big challenge. It's also to some extent about how to think more generally about huge strategic issues related to technology development. So I thought I'd begin by, I'll come to superintelligence by and by, but begin by giving some of the background to this, why I'm interested in it, and some of the other work that we are doing at my institute. So we're a bunch of people there, some mathematicians and philosophers and scientists who are trying to apply careful thinking to the really big picture questions for humanity. One diagram that I sometimes use to try to motivate this is the one you see in front of you here, where we plot two different axes. You have time on the x-axis, and then on the other axis some measure of capabilities, like technological advancement, maybe a level of economic productivity that a civilization might have. So we can define a narrow band on that capability axis that constitutes what we take to be the normal human condition. The thing that we take for granted, the idea that you get up in the morning and then travel into an office where you sit maybe in front of a computer and do your day's work, where you have more than enough to eat. All of these things being, if one takes a step back, enormous anomalies. Obviously on an evolutionary timescale, for most of the time there were no humans around, but even on a historical timescale, for almost all of history, we were in a Malthusian situation where average income was at or close to subsistence. But once one zooms out, one kind of recognizes very quickly just on how anomalous this thing that we take for granted, like the way things are supposed to be, really is. In space, likewise, the crust of the Earth is very anomalous in this vast, mostly ultra-high vacuum. We're floating around on this little speck of resources. So anyway, so that is kind of the human condition there, where we might and have oscillated up and down. You know, maybe there's like a setback or a depression or a big catastrophe, and then we climb back. But outside of that, there are like vast tracts of other possible conditions, other conditions than the human condition. We could imagine slipping below some lower bound on that interval where we have too little capacity to survive. There, in population biology, there is a concept of a minimum viable population size, which is roughly analogous here. Once you have too few individuals left of a species, the species dies out because you don't have enough genetic diversity. If we went through that lower bound there, then there is a kind of stable state, an attractor state, which is extinction. Once you are extinct, you tend to stay extinct. And I think that there are two attractor states. That's one, and the other is what's kind of shown by the upwards arrows there, which is that I think that once a civilization manages to make it through to technological maturity, perhaps initiates a process of space colonization where it starts spreading uniformly at some significant fraction of light, then it might have a very low probability from then on to go extinct, and it might with very high probability just continue on like that, acquiring a large fraction of all the resources that are in principle accessible from our terrestrial starting point, until in the fullness of time the expansion of the cosmos makes it impossible to acquire any more material resources. So there's a finite bubble that we can in principle access if we travel at the speed of light, and we won't be able to travel at the speed of light, but maybe at some significant fraction of that. So there are these two possible attractor states. And I think that the longer the time scale you're considering, the more likely it is that we will break out of the human condition in either one of these two directions. And that then leads us to this concept that I introduced back in 2002 or something of an existential risk. which is very similar to an extinction risk. An existential risk is a risk that either threatens the extinction of Earth-originating intelligent life, or threatens to cause the permanent and drastic destruction of our potential for realizing value in the future. So going extinct is one way we could destroy the entire future, but there might be some other non-extinction scenarios as well. If maybe you could imagine some global oppressive tyranny that, if permanent, it could also count as being roughly as bad as an extinction event. Maybe with new technologies that would make it impossible to overthrow it, with very advanced surveillance capabilities, or with some new technology that could make it possible through psychological or neurological techniques, maybe to modify people's desire or something like that, so that you could prevent overthrow. And the reason why this concept is important, I think, is that if one has some view of value where fundamentally it doesn't matter whether somebody's happiness or suffering is taking place here or in some other place of the world, that value is not relative to spatial location. One might also think it's not relative to temporal location, that fundamentally a given amount of experience is worth the same from a basic moral point of view, whether it happens now or in 100 years or a million years. If one has that view, then there is just so much more of possible future than there is of present, that you get very robust to the result if you crank the numbers, that even the slightest reduction in the integral of existential risk will be worth more in expected utility terms than any intervention you can do that would only have a local effect. So curing cancer or eliminating extreme poverty would have a much lower expected utility than even reducing the level of existential risk by 1/100th of 1 percentage point from this particular kind of ethical perspective. Now, I think maybe there are additional moral considerations one wants to bring into the picture, but at least it's interesting to isolate out this component and see what it would imply. So if we look at the set of existential risks, there are different ways to carve them up. You could make a distinction between risks arising from nature and risks arising from human activity in some way. If you do that, and this is maybe one of the earliest findings of the field of existential risk studies, is you quickly realize that if there are going to be any really big existential risks in this century, they're all going to come from human activity. Our species has survived firestorms and earthquakes and volcano eruptions and asteroids for 100,000 years. So it's unlikely any of those will do us in within the next 100. But we humans are introducing entirely new phenomena, entirely new kinds of hazard into the world that we have no track record of surviving. So I think those are the places where one would most likely find existential risks. Another way of sort of framing that point is by thinking in terms of this metaphor of a big urn with balls in it, representing possible discoveries that we can make. So over time, we pull up different balls from this urn. We invent new technologies. We come up with new ideas, new processes. And throughout history, we've extracted quite a few balls. Now, on balance, they have been a great boon to human society. Our current abundance is due fundamentally to these ideas that we have discovered. But some have made mixed blessings, like the gray balls here in this picture, that have done both good and bad. And maybe there are a few balls we have extracted, inventions that we would have been better off without, although it is hard to think of a lot of examples in that category, but you can think of some maybe chemical weapons or maybe nuclear weapons or different torture instruments or something like that we would have been better off without discovering. But so far we have not discovered one of these black balls in the urn. What would that be? Like some kind of idea or innovation such that once made it would spell the end of the species that discovered it. Well, perhaps it could be something like a very potent destructive capability that would also be very easy to produce. Let's run a little historical counterfactual. So a bit over half a century ago, physicists discovered fission energy, and then that led to the Manhattan Project and the nuclear bomb. In a sense, we were lucky that it turned out that to create a nuclear weapon, you require these very rare and difficult to obtain raw materials. You need highly enriched uranium or plutonium, and those are difficult to make. you need like large facilities consuming a lot of energy, big footprint, working for a long period of time, and then you can produce a nuclear bomb. So that limits the number of actors that can have access to them. But suppose it had turned out instead that you could have made nuclear weapons by some simple method, like baking sand in your microwave oven, or something like that. Okay, so now we know that physics prohibits that, right? You can't, physics is not such that you can build a nuclear bomb by baking sand in a microwave oven. But before we actually did the relevant physics, before we developed nuclear physics, how could we have known? Like, it could have turned out either way. So we were lucky that it didn't turn out that way. But if it had, we had developed the right kind of physics that would have revealed the possibility of unleashing this destructive force through a very simple mechanism, then we probably would have been doomed at that point, because we don't really have the ability to uninvent things. We don't have the ability to pick a ball that looks too ominous and put it back into the urn. So a broad class of existential risks, I think, are of this nature, that it will turn out that this urn, which we haven't yet exhausted by any means, contains some black ball like that. And then if we keep pulling balls out of it, eventually we will come upon it, and then that might be the end. So if we think a little bit more concretely about some possible technology areas where there could turn out to be such black balls, I've listed a few here. Machine intelligence I'll talk more about in a second, but there are others like synthetic biology, molecular nanotechnology. These are technologies that could be used to do an enormous amount of good, but they will also radically perhaps increase human power to affect the external and the internal world in the future, a few decades from now. And that power might be used for all kinds of purposes. You notice at the bottom of this list, I've entered a number of these unknowns as well. This is another important point to bear in mind when thinking about existential risks, which is that if we look at all the ones there at the top, if somebody had been asked the same question, what are the biggest existential risks 100 years ago, none of those would have been mentioned. Obviously not artificial intelligence, because they didn't even have computers back then. Synthetic biology wasn't a concept, so they couldn't have thought of that, nor molecular nanotechnology. Maybe they could have worried about totalitarianism. But all the really big existential risks now have been conceptualized only in recent decades. So over the next century, it's quite possible that we will conceive of additional ones that aren't yet on our radar. So there is a couple of different possible ways to respond to this. One is, I think, best expressed by this random commenter on some blog, Washbash. He said, I instinctively think go faster. Not because I think this is better for the world. Why should I care about the world when I'm dead and gone? I want it to go fast, damn it. This increases the chance that I have of experiencing a more technologically advanced future. And I think that if the question we're asking is what would be best from an egoistic point of view, then Washbash, I think, is essentially correct. The default outcome without any radical technological upheaval, I'm sorry to report, is that we all die, just from aging. We all kind of have a few decades here, and then time runs out, and that's it. The only possible way that we could somehow tap into this cosmic potential of these billions of years and all of that would be if there was some radical technological upset, some superintelligence is invented, or a cure for aging, or some rule of the game would have to radically change. So the more we push forward, the more we shake things up. Maybe the probability is still very small, but maybe there could be like a 2% probability instead of a 1% probability that something radical will happen. Also, even aside from this potential for an extremely astronomically long life, we could benefit from the higher standard of living and all the cool gadgets that might be developed with faster technological progress. However, if one is asking a different question, not what would be best for me, but what would be best impersonally conceived, then I think one gets a different answer, something closer to what I call the principle of differential technological development. So the background to this principle is that we might accept, as I think we should, some sort of moderate form of technological determinism, in the sense that if there is some fairly general purpose technological capability that could be invented and that has a lot of useful applications, and there are useful applications in the precursor technologies leading up to it, then probably those technologies will eventually be developed. So that it looks very infeasible to think that we could permanently ban or prohibit the invention of some general broad class of technology. If one holds that, then I think this becomes a better guiding principle. It says that we should retard the development of dangerous and harmful technologies, especially ones that raise the level of existential risk, and accelerate the development of beneficial technologies, particularly those that reduce the existential risks posed by nature or other technologies. So the idea here is that even if we are basically incapable of deciding whether or not a technology should ever be invented, we can affect the timing of the technologies, exactly what point they are developed. And this, if we couldn't do that, then there would be no point in funding technology research at all, or it would just be a waste of time if we could literally make no difference to when the technology was developed. So presumably on the margin, we have some ability to make some technology happen maybe a couple of months sooner or a couple of months later. And that can make an important difference, particularly insofar as it affects the sequence, the order in which different technologies are developed. If there's going to be a bioengineered pathogen, and there's going to be also at some point like a general purpose vaccine or antidote, then you want the vaccine and antidote to be invented before the pathogen. If there's going to be machine superintelligence at some point, and there's this other possible technology of like control technology of ensuring a beneficial outcome of superintelligence, we want that control problem to be solved before we solve the problem of how to create intelligent machine. And so in general, I think we can organize our altruistically motivated thinking about the big picture and future technologies better if we think about how to change things in the margin and what would be the most desirable sequence of development of different technologies. And we can generalize that slightly. If you conceive of three axes here, so technology on one, this is basically the same notion as capability on the earlier graph. And then perhaps another graph where we depict global coordination, our ability to solve global commons problems, prevent arms races and wars and pollution of common resources and so forth. And the third axis you can draw maybe on wisdom and insight, like the understanding of what beneficial purposes are to which we could put our technological might. Then it might well be that the best possible state that we want ultimately to aim for, the place where I've drawn this sun, requires us to have a huge amount of each of these, like super advanced technology, great global coordination, and deep wisdom, so we can use this technology for wise ends. That might be the only way you could have like really the best possible state. That still leaves open the question though, what to do in the interim from the position where we are now. It might not necessarily be the case that increasing in either of these three dimensions moves us closer to our goal. Well, it moves us closer to our goal, but it might not make the goal more likely to be obtained. It might be, for example, that there are certain technologies, even though eventually you want to obtain them, you would want us to obtain them only after we have first developed better global coordination. If there is a technology that could be used to do very destructive weapons and also could have some beneficial civilian uses, then maybe in utopia we have that technology, but maybe we only want it after we have first figured out how to achieve world peace. So much by means of setting the general stage here. And the reason why I have been doing work on superintelligence is precisely because it looks to me like one of the biggest existential risks. Not right now, obviously, but that we will confront. And moreover, one that might be relatively susceptible to attempts to make it a difference to it. Like it's one that we might be able to do something about. There are two broad ways to achieve superintelligence that we can consider. So you could think of enhancing biological intelligence. And over evolutionary timescales, there have been vast leaps in biological intelligence. Or machine intelligence. So right now, biological intelligence is still far ahead of machine intelligence. If we're talking about general intelligence, like machines beat us in particular domains, but they don't have the same general purpose smartness, the same powerful learning algorithms that we have. However, machine intelligence is improving at a faster clip. So this slide kind of leaves open which one we'll get there first. We can consider more specifically different ways in which each of these could be improved. So with biological intelligence, I think the first way that it will become possible to really seriously boost general intelligence in the human brain will be through some kind of genetic intervention, maybe genetic selection. And I probably won't have very much time to talk about that, but we can bring it up in the Q&A if you want to. We can also consider ways in which we can improve our collective intelligence by developing better institutions or information technologies that enable us to pool our different processors more efficiently. You can imagine kind of some mixture between brain and computer, the cyborg route where you like implant things. Now, I don't believe that that's where the action will be. I think the idea of implanting stuff, well, I think it might be useful for various people with disabilities that you can like replace, like if you have a severed cord, spinal cord, maybe like creating a bridge there would be really useful. But I think it's going to just be very hard to significantly enhance the capabilities of a normal, healthy adult by implanting stuff in your body. Enhancing it in a way that you couldn't more easily do by just having the same chip outside of yourself. So I ask like with people, what's the use case for this? Well, wouldn't it be great if you could like access Google just by thinking about it, by having a chip in your brain? Well, I mean, I access Google all the time. I can do it through my laptop. I already have like a really nice interface, the eyeball, which projects 100 million bits straight into the brain per second. And moreover, has like all this dedicated neural wetware to process that visual information. It's really hard to do better than that by implanting some stuff in the brain. And in any case, the bottleneck is not really our ability to pump sensory information into the brain. It's our ability to make sense of it. So the first thing the brain does with all this visual information is to throw away almost all of it and just extract out relevant higher level features. So I don't think that's very important. Machine intelligence, though, I think, is ultimately where it's going to be at. And so the proposal is sometimes suggested, so like I'm going to mention why like the machine intelligence could be a dangerous thing, that one reason to pursue biological cognitive enhancement would be so that we could sort of keep up with the machines. Like maybe the machines will become smarter and smarter, but if we enhance humans, then maybe we could stay ahead. I think that's incorrect. Biological cognitive enhancement in humans, I think, will only hasten the day when machines overtake us, because the smarter we get, the better we will be at making progress in artificial intelligence. So it will not be a way to keep up with the machines. It might nevertheless be beneficial in as much as we might then be more competent when we are finally at the point where we're designing our intellectual superiors. That would be a good thing, I think. But it wouldn't remove the question of what to do when machines get smarter than us. So if we look at that, well, I'm going to skip over this biological enhancement stuff. If we look at AI then, or machine intelligence, like there are various milestones that the general public are aware of. Every once in a while, the computers do something remarkable, and there's like a media blitz on that. So Deep Blue, when he beat Kasparov, more recently the Jeopardy quiz show. So those kind of register on the public conscience. But under the hood, there is a lot of progress in machine intelligence that consists of new algorithmic techniques being invented. Like a lot of these can then be used in many different areas and application areas of AI. And so you'll notice that so this is just a sampling of kind of like ideas and progress that have occurred. Almost all of these are relatively recent, as in within the lifetime of some people who exist today, which is not, again, that surprising. We've only had computers for a bit over half a century. And a lot of these ideas you couldn't really develop realistically before you had computers. So in the scheme of things, this again is not that long. So if you think, well, people have claimed AI will be coming for a long time now, it still hasn't come, so it will probably never come. Well, that last step is a bit suspicious. We've been at it for 5 or 6 decades. That's not really that long in the scheme of things. A couple of these things were developed before computers, like logic and decision theory. So these were more basic mathematical understandings. We also find that if we look at the performance in some particular domain, like chess computing, where we can clearly measure the rate of progress, so you have these ELO ratings of chess players, you find that roughly half of the progress that has occurred has been due to algorithmic advances, and roughly half due to improvements in hardware, computers getting faster. So as a rule of thumb, that seems to hold true across a number of different areas where machine intelligence is applied. Like the exact proportions vary, but it's like they both played roughly equal parts, with the Moore's law there that you can see in the lower graph. So the one possible path towards machine intelligence is like continued progress along this part, like more of these. So there's like some number of these missing. We can't do human level machine intelligence today. There's like one or more likely a bunch of these basic ideas that we don't yet have. You'd need some kind of theoretical breakthroughs. We don't know how many of these. We could do those in principle, and then we could have machine intelligence. Another path is we have an existence proof of a general intelligent system, which is the human brain. Okay. So another path is by reverse engineering the human brain. There are different versions of this, like at the minimum, you could just do neuroscience and maybe draw inspiration from what you find about the algorithms and architectures used in the human brain. And then without worrying too much about biological realism, do something vaguely similar perhaps in computers. Or you could try to do a more accurate replication of human neurobiology. And at the limiting end of that approach would be literally trying to copy a human brain onto a machine substrate. So this is the approach known as whole brain emulation, where what you would do is you'd take a brain, freeze it or vitrify it, and then slice it up into thin slices, feed each of those slices into an array of powerful microscopes, take pictures of them. That would result in a stack of pictures that you would then use automated image recognition software on to extract the three-dimensional neural connectivity matrix. Then combining that with neurocomputational models of the different types of neurons you would identify in there, and then emulate that in a powerful computer. And if all went well, you would then have transferred the intellectual process of the original brain into a machine substrate. In the limiting case, you would have this human mind living now in a computer with maybe the same memories and everything, the same capabilities as the original biological brain. So we are very far from being able to do something like that today, obviously. This is roughly the state of the art. The picture there at the upper left is an electron micrograph of a little piece of neural tissue, and you can see it's like a cross-section where you can see some axons and synapses. The block there is what you get when you put the whole stack of those pictures on top of one another. And in the upper right corner, you see the result of automated image recognition, which, using the data from one of those stacks, can extract the information about which neurons are connected with which. But there's still a lot more work that would have to be done before anything like that could actually succeed in emulating a whole brain. I mean, at the moment, we still don't have this for C. elegans, which is a roundworm with 302 neurons. That's still like a cutting-edge research product to try to achieve it for that. So we know that we're not close to this, because it would require some extremely advanced enabling technologies that we don't yet have. What this approach would not require, however, is any new theoretical breakthrough. It would not require us to understand how cognition works at a higher level. It would only require like advanced enabling technology and an understanding of how the parts of the brain work, like individual neurons, which is something we already have reasonably good models of. So it's an approach that we can be, I think, somewhat confident will eventually get to the goalpost, although it'll probably take quite a while before it does it. And it might well be that it will be beaten to the finish line by the synthetic approach, where you don't try to mimic biology, but you just do it from scratch, like most AI has been done. It's an open question which path will get there first. And it's worth bearing in mind also the point about biological enhancement, that even if these problems turn out to be too hard for the current version of humans, that by the end of the century, there might well be a significantly smarter version of humanity that will be doing the research, and then an even smarter version after that. So the existence of these multiple pathways increase the probability that the destination will eventually be reached, I think. The applications of improvements in machine intelligence are numerous. That also increases the probability that there will actually be motivation to continue to move along this trajectory. They are in use all over the economy today. AI researchers sometimes complain that as soon as something they're working on actually starts to work, it's no longer called AI. It just becomes software. So there's a bunch of techniques that were initially invented in the field of AI that we now just take for granted. And we don't think of them as very exciting, even though before they were invented, they were seen as these like great milestones. So even chess is like that. Like today, we just think, yeah, computers do that, so what? It's just a matter of calculating out moves. But before, it was seen as like the epitome of human intellection, like the greatest brains thinking about these complex strategies, something that perhaps humans would never be able to do. There's also been a recent spat of acquisitions in the field of AI over the last year or two. There's like a kind of talent race on, it seems, to acquire. There was a company, DeepMind, that was acquired by Google last night that we had been working with quite closely, and a number of others. It's not clear how much one should make of that. There have been throughout the history of AI at least two previous sort of hype cycles, followed by disillusionment and AI winters, and then renewed hope and excitement, and then another wave of disappointment. And this is like the third wave of excitement. So, maybe at some point it will happen, but whether it's this wave of excitement or whether there will be a few more cycles of disappointment followed by excitement is unclear. We can see in game AI where it's kind of easy to compare AI and humans that they do beat us in a range of different games, but they kind of still suck at sort of common sense understanding. The question of when is interesting. We did a survey of leading AI experts last year, and one of the questions we asked was, by what year do you think there's a 50% chance that we will have human-level machine intelligence? And the median answer to that was 2050 or 2040, depending on precisely which group of experts we surveyed. We also asked, by what year do you think there's a 90% probability that we will have human-level machine intelligence? And as you can see, the median answer there was 2070 or 2075. My own view is slightly different here. I think maybe the 50% is fairly reasonable, but there should be a big uncertainty on both sides of that. It could happen much sooner or much later. I think a 90% chance that we will have it by 2070 or 2075 is overconfident. That there should be a fatter tail. It could take longer than that with more than 10% probability, in my view. We also asked, if and when we do reach this, I should say as a footnote, the probability there is conditional on human civilization not collapsing and that science and technology continues. So maybe you would cut away a few percentage points if you didn't. So we also ask, like, if and when you do reach human-level machine intelligence, how long will it be from there until you have superintelligence? And you can see the answers here. Within 2 years, 10% probability. Within 30 years, 75%. So again, my view differs, and here it differs for reasons that I go into in the book. I think there's a much higher probability. Like, I'm quite agnostic as to when we will have human-level machine intelligence. The truth is, we don't know. We should think in terms of a broad, smeared-out probability distribution. I do think we have fairly good reasons for thinking, though, that if and when we do reach that point, we will quickly thereafter have superintelligence. We should assign a significant probability to the intelligence explosion hypothesis. The hypothesis that at that point, you might get very quickly, this transition might be steep from humanish level to superintelligence. And there are a bunch of reasons for that, which I can only sort of hint at here. But we first have to distinguish these two questions, right? The time from here until takeoff, and the time of how long the takeoff takes. In the popular media, these generally get conflated into one big sentiment of either excitement or skepticism. But there are two completely different questions. So as I said, I'm very agnostic about the first one. I think I'm assigning a fairly high probability that the second one will be fast or intermediate, although nothing like certainty. So things depend on this. A fast takeoff, where maybe within minutes or hours or days, so like something like that, we go from human level to superintelligence. They pose a big challenge in the sense that it's too little time for humans really to react, to create some new solution that we haven't already put in place. We have to solve the control problem clearly before we get an intelligence explosion, if the takeoff will be fast. Conversely, if the takeoff is very, very slow, if it's going to take decades and centuries of incremental progress after you have human level until you get anything really super intelligent, then maybe there is time to develop new governance institutions and try out things that work, and if they don't work, try something else and build up a consensus, educate a new generation of experts. So it matters which of these scenarios you think is likely to play out. Also, it matters in another way, in that if the takeoff is fast, there's likely going to be only one. Like if you have different technology products, different software products or whatever that are racing to develop a new technology, maybe they are running neck to neck and they're quite close, but the leader is not like 2 minutes ahead of the follower. Like usually they are a few months ahead of the follower, something like that with technologies, maybe a few years. So if the whole transition is going to be over in a couple of weeks, then it's likely that the leader will have completed the transition before the next follower has even started it. So you then have a world with one system that is radically super intelligent in a world where there is as yet nothing that is even halfway super intelligent. And that then suggests a singleton outcome where you have a world order where at the highest level of decision making there is only one decision making agency. And this first AI will then maybe be in a position to pattern the future according to its preferences. By contrast, if you have a slow takeoff, then you're more likely to get the multipolar outcome, which raises a very different set of concerns, not necessarily less serious concerns, but different ones. So there you're much more likely to have a world where you have economic dynamics, economic competition, and evolutionary dynamics among this population of digital minds coming into play. You could immediately, if you think about it, like have a rapid population explosion. So suppose you even have just human minds, but that are digital instead of biological. So one of the things you can do is to make a copy of it, right? We know how to copy software. So instead of it taking 20 years to make a new like adult who can work, then that takes a minute. And you can do things like move them to a faster computer. Like if the computer is 1,000 times faster, they think 1,000 times faster. You get like weak superintelligence quickly, and you get in a wide range of multipolar scenarios this population explosion, where the population of digital minds grows until the income of digital minds drop to subsistence level. We keep making more of these machines until the income they earn is just the same as the cost it takes to produce one, the hardware and the electricity bill. So the wages, as it were, that these digital minds earn drop to subsistence level for digital minds, but which is then much lower than subsistence level for biological humans, since these are more efficient. They just require a little bit of electricity rather than houses and cars and food and stuff. And so humans then, in this type of scenario, may become unable to make a living by wage income and would only have capital income to rely on. And one can then ask how likely it is that we will manage to preserve the legal system of capital ownership and so forth in a world where maybe there are trillions and trillions of these digital minds that they're getting smarter every few days and are thinking much faster than us. Eventually, maybe there's just so much, the center of gravity moves so completely over into this digital realm that maybe they can find a way to expropriate us. And so I'm not going to discuss that in more detail. But just to say one thing about the singleton scenario, where you have the fast takeoff, and therefore maybe the first superintelligence becomes extremely powerful, and then able to shape the future according to its preferences. So a lot in that kind of scenario, obviously a lot depends on what those preferences are. And to begin to think about that, the first thing one has to do is to not anthropomorphize artificial agents, which is a big stumbling block. So if you look at how sort of alien minds, like the closest maybe like space aliens that have, like science fiction authors have described about them, but in almost invariably described in extremely anthropomorphic terms. So you see like these typical sort of old science fiction book covers where it looked like the main thing that the space alien invaders would want is like to kidnap human blondes. But if you start to think about it, you realize quickly how, like, if you actually, from an evolutionary point of view, like what a space alien would find attractive would be like a green, scaly, slimy thing, not like a human thing. So one has to like look a little bit more at foundational theories rather than like match to the closest stereotype. And so there are two principles that can help us think about AI motivation. The first is what I call the orthogonality thesis, which says that intelligence and final goals are orthogonal, that more or less any level of intelligence could in principle be combined with more or less any final goal. There is no necessary connection between being very smart and being either good or evil or having any other particular desire. That all depends on the particular system and how it's built. On the other hand, there is also this instrumental convergence thesis, which says that we can identify several instrumental values that are convergent in the sense that their attainment would increase the chances of an agent's goal being realized for a wide range of final goals and a wide range of situations. So whatever, or almost whatever your final goal is, there are these various instrumental reasons for pursuing different things. So suppose you had an AI whose only goal in life was to make as many paper clips as possible. So maybe it was constructed to run a paperclip factory, or then it became too smart. So now you have this artificial agent with the final goal of maximizing the number of paper clips that are produced. And you can pretend that you are this agent. So what would you actually do? Well, you would first quickly realize that you would be much better off without any humans around, in as much as humans maybe would one day decide to switch off if they could. Then there would be much fewer paper clips if you were switched off. So it would be better if there were no humans. So already here you have an instrumental goal of eliminating the possibility of human interference. Also, human bodies consist of atoms, and those atoms could be used to make some really nice paper clips. So there are multiple reasons why the maximal realization of this arbitrary goal of making as many paper clips as possible would be inconsistent with human survival or the protection of anything we care about. But now you can substitute, instead of making paper clips, almost any other goal you can think of, like calculating digits of pi. Well, for the same reason here, you want to get rid of humans and you want to maximize the number of processors around. So you want to transform the Earth and then as much of the universe as possible into more powerful computers so you could calculate more digits of pi. It turns out to be actually very difficult to even conceive of a kind of goal that would not imply that. You would have to find a way to somehow embed human values into the final goal of the seed AI that would become the superintelligence. And that raises both difficult technical problems that are as yet unsolved, how you would actually do that with subhuman AI, like putting human values in there so that it retains those values as it becomes superintelligent. And also philosophical problems, in as much as even if you had a solution to that technical problem, there is still then the very difficult question of exactly which values we should choose to endow it with. And remember, in this scenario, a lot would depend on this, because this would be the pivot on which the entire future swings. So the AI, if it really became superintelligent and able to shape the future according to its desire, it would then shape the future according to this desire that we had selected for it to have. And so both of those are areas where a lot of really difficult intellectual work remains to be done that needs to be completed before we figure out how to build AI. So think back again, just to round up, to this principle of differential technological development. It seems to me that we have reason to try to accelerate work on this control problem so that we'll hopefully have a solution at hand by the time we solve this competence problem. And maybe we have a reason to retard the development of AI, although I think as a practical matter, an extra $1 million or an extra talented person will have a much larger effect on the amount of work we are doing on the control problem than on the amount of work that is doing on the AI problem. Just because there are so many fewer people working on it at the moment, it's really hard to make much difference to how much the world invests in machine learning. You really can't affect that much, but you can make a big difference to how much effort we're putting into solving the control problem. So I'll open up for maybe some Q&A now, and look forward to hearing what you have to say. Thanks. Hey everyone. So we're going to do, as long as we can, of some Q&A. If you're interested in asking a question, we're going to form online over on this side. I don't have a microphone. So if you're interested in that, go ahead and start moving over this direction. Before we start that though, as you all hopefully know, we have a membership drive going on right now, and anyone who became a member of C2ST in the last few weeks got entered into this drawing, and you're going to win an autographed copy of Dr. Bostrom's book, and also a movie. So get ready for this. We're going to do the
all right.
right now. So
Okay. Okay.
Pick one of these, please.
Oh wait, I'm not randomized enough. I gotta. Okay. Okay. Are you ready? Courtney Smith, or something sounds like that. You're here? Congratulations.
So come see us after and give us your address, and we'll get your prizes to you.
Question about infinite computing, what it means anything and what the relation is to what I was talking about. So I'm not sure exactly how different people might define it. If one means it literally, then it looks currently as if it's not consistent with the laws of physics as we know them. There are fundamental limits to the density of information processing. If quantum physics imposes limits to how much information you can get into finite volume, if you try to push more matter into finite volume, then eventually you make a black hole. The ultimate physical limits, though, are still far beyond our current technological capabilities, so there's a lot more room to expand there. I would say that it looks, from the point of view of reducing the existential risks from AI, undesirable to have faster progress in hardware. Basically, the thinking is that if we're going to get machine superintelligence, it's best if we get it in a way that forces us to understand what we're doing at a deep level. So the more hardware you have, the greater the chance that you could do some brute force method for finding algorithms that turn out to be intelligent. Clubber together some things, maybe something inspired by neurobiology, add some genetic algorithms, just pump a lot of computing power into it, and maybe you could get that to work. That's undesirable. It's better if we're building kind of system where you can prove mathematical theorems and you really have to really understand at a deep level exactly what all the parts are doing. And the more hardware constrained you are, I think the more you're forced to develop that deep understanding. Yes, ethics and morality, what part does that play? Definitely, it should be a big part. It's striking if one looks back at the pioneers of AI back in the 50s, where they were quite confident that they would soon reach human-level machine intelligence. So now that clearly was overconfident in retrospect, but before they had tried to solve the problem, and maybe it wasn't so unreasonable to think. But what's striking is that although they thought that they would have, many of these leading guys, that they would have AI within 10 years, they didn't seem to hardly ever, if at all, have stopped to ask, like, what happens next if we are successful in this endeavor? Like, it is as if their imagination muscle had so exhausted itself in conceiving of the radical possibility of having machines that are as smart as humans that they couldn't then think of the further obvious step that shortly thereafter we will have superhumanly intelligent machines. Nor asking, the obvious question whether this would raise any sort of ethical issues or safety issues or anything like that. So today, hopefully, it would be impossible to be so completely oblivious to the consequences that you wouldn't even ask the question. But still, I think we have a long way to go. So it should be a big part of it, but it's not sufficient. We need something much more than just sort of hand-wringing or even philosophical progress in moral philosophy. We also need the solution to some really thorny mathematical and technical problems to pull this off.
Thank you very much for the control.
Yeah, so could I elaborate on the control problem, and does cloud computing and parallel computing make it harder or easier? Broadly speaking, there are two approaches to this control problem. On the one hand, you can attempt capability control methods. These would be ways in which you would try to limit what the system can do. So maybe you put the AI in a box and you unplug the internet cable. Perhaps you only allow it to communicate by typing text on the screen, maybe only answers to questions that we ask it. You try to clip its wings in different ways. Now, I think this kind of capability control method will be a useful adjunct during the development stages before you actually have a superintelligence, before you're ready to launch it as an extra safeguard. I think ultimately we can't rely on it, partly because at some point the human has to interact with it. Like if you literally only has a box with no interaction with the rest of the world, it's like completely inert, right? It doesn't have an impact. So at some point there's going to be this human gatekeeper who's going to interact with it, and humans are not secure systems. And we know that because even human malefactors often succeed in manipulating or persuading humans to do their bidding. And so if you have a superhumanly powerful persuader and manipulator, the only safe assumption would be that eventually it will manage to get out of the box, either by talking its way out or perhaps finding some way to hack its way out of the box. The other approach to the control problem is motivation selection. So instead of trying to, or in addition to trying to limit what the AI can do, you try to engineer its motivation system in such a way that it wouldn't want to do things that are harmful, even though it could. And so this is what I alluded to at the end when I was discussing this challenge of how to define a final goal and then get it in there. Now, as to the computer network security protocols that we have, my guess is that it's probably not going to make much difference one way or the other regarding the problems of superintelligence. I think there are other reasons here now where there's obviously a lot of interest in computer security. But I think that the work going into doing that is largely independent of the kind of work that would either make the superintelligence problem easier or harder to solve. I think that the key challenge is in the actual intelligence part, not in the number of devices that the intelligence initially has access to. Yes, so the question is on the Future of Humanity Institute and the Center for the Study of Existential Risk. So the Future of Humanity Institute has existed now for 10 years or so, like slowly growing. So we are a multidisciplinary, we are a research institute. The Center for the Study of Existential Risk is a new outfit that we are trying to help create at Cambridge University, Cambridge, UK. And there is some effort underway by Professor Max Tegmark here at MIT. And there's this group, I think you mentioned in the introduction, affiliated or attached to Berkeley, but it's an independent nonprofit, the Machine Intelligence Research Institute. So these are the beginnings of a kind of organizational infrastructure, which are trying to bring talent to bear on, well, both the specific problem of AI safety, but also more generally, the general problem of identifying existential risks and finding the most efficient ways of reducing them. And even more generally, finding better ways to think about these kind of prioritization questions and macro strategic questions that arise if you really try to do things that are best, all things considered, including long-term consequences. But it's at a very early stage, so I did a little literature survey just a couple of years ago, and I discovered that there's a lot more paper published on the dung beetle than there is on human extinction, by an order of magnitude. So it gives some sense of like how out of proportion our allocation of resources and attention are. It's not the case that the most important problems are getting the best and the lion's share of our attention and resources. Conversely, for an altruist, to somebody like young and energetic or idealistic or in possession of some influence, there's a lot of opportunities maybe because the status quo is so kind of enormously ill-calibrated to what really seems to matter, to try to help push it in the right direction. So ultimately, I mean, that could be this could be scaled up by a couple of orders of magnitude. Every good university should have like some research center on this, and then it should be coupled with other organizations that are actually affecting change in the different areas, synthetic biology, like people working on the AI thing, thinking more systematically about the whole panoply of risks.
Gap between two.
Yeah, so question about risk externalities and how whether the education system is doing a good job in preparing people to think about it. So, so we're all familiar, I guess, with like the concept of a global public good, or like, so something like the global atmosphere is like this big sink. Everybody can benefit from it, but if you pollute, you're only like 1/7 billion of the number of people who are maybe suffering from the pollution. So there's a tendency to pollute too much. Like existential risks involve an even trickier form of global good, not just the global good, but the global transgenerational good. So there are these future generations whose very existence are on the line, a large number of these future generations. If it had been possible to like make bank transfers like backwards in time, you could imagine that future generations would have been willing to pay us a great deal to up our game to reduce existential risk a lot more. Now, that transaction is kind of blocked by the laws of physics, but it makes it possible initially that from an impersonal or altruistic point of view, there's an underinvestment in these transgenerational global goods, and that's indeed what we find. And for the same reasons, but even more so, that there tends to be an underinvestment in like preserving ocean fish stocks or providing other global goods. Now, I think maybe part of the solution here is better education of the form that providing the tools and concepts and the intellectual sophistication to actually think meaningfully about these big macro strategic challenges that humanity faces. I mean, a part of the problem, I think, is also a lack of will, that most people just don't care that much about the future when it comes down to it. Which makes it all the more important, in my view, then, to husband the part of us that really do care. So that some people do care to some extent, but that's a fairly limited amount of our overall sort of resources that we're willing to devote to that. But at least make sure that that small fraction is allocated optimally, rather than squandered on a lot of sort of feel-good projects, or just jumping on the latest bandwagon where there's some popular cause. At any given point in time, there's like one cause célèbre, like on the global level. So now, obviously, global warming. It used to be nuclear Armageddon. And back in the 70s, if some of you remember, it was like the overpopulation crisis. And in the earlier days of last century, I guess, I don't know what it was then, maybe fears of genetic decay or racial miscegenation or something. But at each time, there's like one big challenge. But the thing that arises to the forefront of the global consciousness is not, it can be, but it's not necessarily the thing most worthy of this kind of attention. So I think like nuclear Armageddon was a very big risk during the Cold War, and it was good that people paid a lot of attention to that. But now going forward, I think there are a lot of major existential risks that have not received as much attention they have, and one can wonder whether the extreme focus on the global warming whether that comes at the expense of attention to other existential risks, or whether it instead sort of preps people to think long term. I'm not sure what the answer to that is. Yeah, so will we have to define rationality to get safe superintelligence? And I think the answer is yes, and there are some additional, so I've been focusing in my short talk mainly on the motivation part. There are some other components that would have to go into an AI that we would also have to get sufficiently close to right. So it's decision theory, it's epistemology. I think they look, based on the work done so far, to be more tractable than the motivation part, but they still have to be worked out. It's worth maybe emphasizing that the relevant version of the concept of rationality for present purposes is this instrumental rationality. Like an agent that is instrumentally rational, in the sense of being able to find the most effective means to achieve some given end, whether or not that end is worthwhile, is potentially an extremely powerful agent, even if it's in some sense crazy by some normative standard, even if the goal it pursues is something we would not recognize as meaningful, even if it's a paperclip maximizer. As such an agent, even though we would not deign to call it fully rational, it could still be an extremely powerful force in the world that could transform the world into paperclips. So we need to worry about agents that are high in instrumental rationality, whether or not they would count as fully rational by the most sort of philosophically thick description. Yeah, so a relation between the simulation argument and these thoughts about superintelligence. So that's like a big topic in its own right, so I'm not sure how much I can delve into it in the short time available, but the simulation argument is a separate piece of reasoning some time back. It tries to establish an indirect constraint on what we can coherently believe about the future and our place in the world. It tries to show that one of three propositions is true, one of which is that we are in a simulation argument. A second alternative is that almost all civilizations at our stage of technological development go extinct before reaching technological maturity. And the third possibility is that there is a strong convergence among all technological mature civilizations. They all lose interest in creating ancestor simulations. So the simulation argument tries to show that at least one of those three possibilities is true. It doesn't tell us which one. But it's one of a small number of arguments that try to, through some kind of indirect reasoning, find some interesting constraints about what we can probabilistically believe about the future. So there are a few others. You can think about the Fermi paradox, the fact that we haven't seen any aliens. Does that tell us anything useful? There's the doomsday argument. So its relation to these thoughts about superintelligence are not fully understood, I would say. So if we were in a simulation, then yeah, we might or might not develop superintelligence in the simulation. So both of those possibilities are on the table. The behavior of the artificial intelligence that might be influenced by the simulation argument. So that superintelligence might not be certain as to whether it is in a simulated reality or in the bottom level physical reality. And that might have surprising effects on its calculation about how to behave in ways that I haven't talked about here. Partly because they are difficult to understand and partly because, yeah, I don't have much time. But so that would be an important kind of footnote. But I think that unless one first sort of has some idea of how things would go without even taking that into account, one has zero chance of knowing how it would go with that taking into account. But there would be no guarantee that we would be succeeding one day in developing superintelligence, even if we were in a simulated reality. Well, so yeah, questions about the epistemology of technological revolutions, in a sense. How could we possibly have the knowledge we would need to apply the principle of differential technological development? So this is a very big problem. Now, it applies equally without this principle. Like, if we're going to invest money in developing technology, presumably it's because we think we can make some guess that on balance the consequences will be beneficial. Otherwise, it's just a waste of money. If we literally could know nothing about what the outcome will be, then we're just squandering our resources. We should do something else with them. So we have, it seems, some beliefs about what's likely to lead to what and whether the upsides are likely to be larger than the downsides. And so we need to rely on those estimates in figuring out which technologies should be accelerated and which slow down. But it is still very true, though, that because the ignorance is so profound, one of the main things that need doing in this area is to try to get better at that. And so developing better methodologies for technology forecasting, but also just a more sophisticated way of thinking about these strategic issues that I have barely touched on here. Because it is very often the case that it's impossible to evaluate one like technology in isolation. You might have a dangerous technology that we would be better off without, and yet it might turn out that we should invest in it and try to get it faster because of the way it interacts with other technologies. And we are very, very poor at thinking in some coherent way about this complicated strategic problem. So anything that could even like slightly improve our ability of such strategic thinking would, I think, potentially pay big dividends in terms of them being able to direct our well-motivated efforts more efficiently. Otherwise, there's a great risk that all our best intended efforts end up actually making things worse rather than better. For many of these levers, it's not clear what the positive direction and what the negative direction is. And that's one of the reasons that I'm started this Future of Humanity Institute and why I think that's an area where I want to focus is that I do think that there's this very dire need for strategic illumination and advancement in our level of maturity to reflect on these big things, these big picture questions for ourselves.
Okay, thank you, Dr. Bostrom.